Now we're ready to talk about evap system leak checks. This is the area where we're going to find a lot of things in the next common piece. Hoses are the most likely area of a vacuum leak, statistically speaking, followed by gas caps. Now the leak check is where the differences in evap operations occur. We're going to go through the 9 most common leak check configurations later on a specific basis so you understand the details of their operation. But for now, let's go back and look at our most basic system, pre-OBDI. Now the hose is about the only thing we checked here with our purge flow sensor, vacuum switch, whatever you want to call it. It detects vacuum. It also runs some checks on the canister purge solenoid. Let's see how that works and talk about what it's going to do. It's, like we said, it's our most basic system. It's a vacuum switch. Now check the vacuum switch operation before going through a long, drawn-out leak check. To do that, you apply a slight vacuum to it to see if the switch opens. Replace the switch if it doesn't open and if it doesn't operate correctly. Because listen, a bad vacuum switch can cause a false leak code and cause you a lot of time. Doesn't take long to test. Let's go have a look at exactly how we're going to test that switch. We're going to take and look at it with our voltmeter. It's got a vacuum hose going to it. We're going to disconnect the vacuum hose and we're going to hook our voltmeter up. With no vacuum present, there should be B plus there. Once we have it B plus and we have our red test lead on pin B here, which in this particular case is a purple wire instead of the pink wire. The pink wire is B plus. It's not going to change. Only the signal on the purple wire at pin B will change. Now we're going to place a slight vacuum on it. If we can pull a slight vacuum, we should see the voltage go open and drop to less than a volt. That means the switch opened with a vacuum. Don't put a mighty vac on and try to pull 20 inches of vacuum. We're looking for a very slight vacuum. Leave one hose hooked up and just see if you can pull a slight vacuum, have it close. Only needs 1 or 2 inches of water to close the switch. But replace any vacuum switch that failed this test. It's pretty straightforward. A lot of P0440s prior to OBDI with this switch. OBDI, we're going to go to a more improved system. We started improving things in 1996. We put in canister vent solenoids, and we're going to start doing a more detailed leak check. Now we're going to treat all the leak codes just like they're a single set of procedures. It's only a matter of how small of a leak we're looking for. And we need to be aware of that for our testing purposes. But here's our 5 most common codes. P0440, incorrect purge, possible leak. That means we tried to pull a vacuum in an OBDI or OBDI system and we couldn't see a vacuum develop. Or it means we had an pre-OBDI with a leak check with the vacuum switch and the vacuum switch didn't close when we had canister purge. 42, 55, 56, and 57 are all leak testing. Different sizes. P0442 is a small leak. P0456 is a small leak. Same code, same meaning, different times. You won't get both of these on the same vehicle. You'll have one or the other. 455, gross leak detected. This is a common one with a loose gas cap. P0457, leak detected, possible filler neck, loose gas cap, missing gas cap. That's another common one. It's a gross leak which has seen a refueling event, meaning we've added fuel to the vehicle recently, and then we set this code. All of these codes have run a number of tests and failed. Now let me say it again. They've all run a number of tests. You'll find out that sometimes the worst case I've seen is a Chrysler will run umpteen different times before it finally sets a leak on their cars. It has to be in the right set of conditions. So a lot of these things take a long time to set. Just clearing the codes isn't necessarily going to fix the car. But you can clear the code, and as long as you don't drive it too long, the check engine light's not going to come back on. If you're trying to get by an inspection, you're probably going to get by because they'll let you pass inspection if this monitor has not run. But if it's run and failed, they're going to want you to go find out why it's leaking. So don't just think because you've changed the cap, cleared the codes, and it didn't come back on a short test drive, you've solved the problems. You probably have not. These codes are pretty specific and have some pretty tough rules. We're going to talk about those rules. But let's talk about testing. OBDI was simple. We treated with a smoke machine. There's no vent solenoid, so what we're going to have to do, if we've got this big leak and our flow sensor is working and we've verified it, now we got to go find our leak. We're going to come in here and select a point to seal off a hose, and then we're going to perform a flow test with a flow meter. We use a flow meter on our system. We're going to be using one that's provided us by Star Technology, Enviro Technology. It's a great machine. We're going to be going into the Schrader valve. Remember, it has a reverse thread, so be very careful. And thread this in carefully. We're in a good seal because we're now going to count on this giving us a perfectly good seal and detecting a seal system as well as low restriction. Since we don't have any other way to seal it, we've had to go into the car and pick some hoses and start sealing off hoses to figure where the leaks are. Keep this in mind because we can use this in other places. This is a point where the system can be divided into sections for testing. Rather than look grossly for leaks everywhere, one of our big theories is, particularly if you're working on a 20,000th leak, is to come in, block off each one of these and see which one is where the leak is, then go from that direction. We'll talk more about that later. But we're going to pinch it off here, for instance. If we pinch it off there and we supply the flow gauge at our test port, we're testing the hose between the canister purge and the canister itself. And we're going to see if that's where the leak is. If that's where the leak is, go back and check the canister purge valve, make sure it's working and sealing. If it's not, then you have a hole in the leak. You can supply smoke then to find it. We're going to talk about why we're going to do this and how we're going to do it. If you have a newer system that has a purge solenoid and a vent seal, like we have here, we got an evaporative emission canister vent and a vapor management valve, purge for a better name. We can close the vent solenoid instead of having to pinch off hoses if we want to check the complete system as a quick check. Now here's what we do. We set our calibration point. If I've got a 1996 up to a 99, I would set it at the 40,000th point because that's the leak I can detect. I'm going to go to full flow, and then I'm going to close off the vent and see if it drops down below the 40,000th point. I know two things now. I don't have a restricted system because the flow is the same. The flow meter should drop from full flow to below the calibration point if we have a good seal. If I do that, I pass the test. Look for an intermittent, like something like a solenoid not working. Cycle the vent solenoid open and closed and see if it seals every time. Make sure there's nothing wrong with the gas cap and the filler neck that could be an intermittent problem. Because if you've had one of those codes and it shows up, it had a specific reason for showing up. So if you've done this test and you cannot duplicate it, spend some time. But you're not going to find anything with a leak test, because if that goes to the bottom, I can pump all the smoke I want and I'm not going to see it come out anywhere. If I've got a leak, that ball will not be at the bottom. Don't waste your smoke and don't waste your time. Before our OBDI, when I didn't have a seal, I've got to go seal the canister to do that test. I don't have a vent solenoid. But if I've got a vent solenoid like this one, different generations, we're going to use that bidirectional testing to activate the vent seal. Look at this system. I seal it up at the output side of the canister. If I can seal the output of the canister, everything in red gets tested. And if I've got a leak, I'll know it. So let's talk about it. This addition of the Vent Seal Solenoid will allow you to seal the system with bidirectional control with a scan tool without grumming around with the car. Now, we might want to go pinch off hoses later. We're not beyond that. And Chrysler vehicles use an alternative approach that does not have an electric vent solenoid. So you're going to have to seal Chryslers with the pinch off. And there's some other versions you'll have to do about that. We're going to talk about specifically. But all these differences we're talking about are going to be covered separately in the unique testing by manufacturer systems. So we'll take care of that and not try to overburden ourselves at this point. The first issue in leak testing with bidirectional control is with a scan tool. We want to talk about that because that makes life easier. Most of the systems capable of finding a 40,000th leak will have a vent seal solenoid. We will show you the ones that don't. We're talking about this solenoid we're going to be using. We're going to come up here, we're going to see when we have no leak, close it up, and it goes all the way to the bottom. We've tested our system, so we're verifying our flow meter. If we have an adjustable flow meter, adjust your flow meter so it comes all the way to the top here. Notice I'm in the test mode. I want to have full flow. Now, the one we use from Star Envirotech has automatic ranging. It goes to the top every time. That's our free flow. Then we're going to hook it into the evap system and see how well it flows. When we put our finger over the end, we're verifying we can get down to no flow. There's nothing wrong inside the hosing, plumbing, going out of our smoke machine. So we're going to set this point right here. We're going to test the flow before connecting the evap system. Then we're going to connect the evap system, and any restriction will drop the ball below this point. It'll drop down somewhere. So here's normal with the flow open. When we have a restriction, it falls between the bottom, obviously, and the top. It's not going to go over to the top. How far it goes up tells us how bad the restriction is. And we expect sometimes to see a small difference between free flow. Now notice here, we have full flow without it. When we hooked it up, it's not too much lower. That's reasonable. We're looking for exceptionally large differences in flow. We don't have big restrictions here. And of course, we want to be able to close it off and seal it up. When we seal it up, either with pliers or with a vent solenoid activation, we want to see it go to the bottom. And we'll talk about the various ways of doing that. And we can close the vent ourselves. If we don't have a scan tool with bidirectional capabilities, we can come out underneath the car, find the vent solenoid, and activate it ourselves. So if we have it, do it. Don't forget all of this leak testing we're talking about. You can confirm this with a service bay test. So if you want to make sure you're not chasing your tail, do the service bay test if the vehicle has it and your software can do it. Then we're going to come in here if we have the right kind of software in the right vehicle and it allows us to change the vent. We can close the vent, use our flow meter to see if the ball drops down below our calibrated point. Find out if you got a leak. If a vent seal is not available, you have to come back to the canister back here and somewhere in the system and start pinching off hoses. And we're going to talk about pinching off hoses because that's really important. On vehicle-specific things, we'll talk about vehicle-specific things of where to pinch off. But you're going to have to block off a hose. If we have no bidirectional on our scan tool and we want to activate this vent seal solenoid back here on the canister, I've got a red wire and a white wire. Now, it doesn't take a rocket science to tell me that B plus is probably going to be red. But I'm going to go get a manufacturer-specific diagram anyway. But what I'm going to do, I'm going to see what that needs to activate. I look at my diagram. Over here on the left, it says evap canister vent solenoid. It's a white wire. There's a red and white going to it, and it's a ground activated. So if I supply a ground to C235, or over here on the white wire at the canister vent, I will activate the vent solenoid and seal it up. Remember, this is exactly what the computer's going to do the testing. So what we like about this is by sealing it up with this vent, we're doing exactly the same thing that the tester is going to do for the software testing of the leak system. And we're going to go down here and we're going to say, boom, it should indicate no flow, or at least something below the set point. Now, we have a set point here of about 40 thousandths, and we'll talk more about that. But we show no leak. If we got an intermittent problem, we need to go and turn it off and on and make sure it closes. We do get dirty vents with contamination that don't work the same every time and sometimes have problems. But I'm going to calibrate. Am I looking for a 20 or 40 thousandths leak? If I've got a 2,000 or later, you might as well start testing with a 20 thousandths. You may get a code for 40 thousandths, but the computer is going to test for a 20. So if you fix the 40, it's still not going to be repaired until you get below the 20. So you might as well start with 20. So here's a 20 way at the bottom down here, and there's a 40 up there. So we got different settings. It's automatically going to calibrate it for us, and we move our little red slider on our machine. We take a crayon marker and mark the side of ones that don't have a slider. We need to know where is this spot for a 20 thousandths leak and mark that spot so we know what we got to get below. And here we go. We got our vent open. We close it. We repeat it back and forth, open and close. It goes from full flow down to no flow on a consistent basis, and we're trying to duplicate our system. If we fail, then things get a little more complicated. If we fail, now we got to try to find a location, particularly with a 20 thousandth leak. Let me emphasize, 20 thousandth leaks are not easy to find. There's a very small amount of smoke coming from it. Worst case scenario, you've got a couple pinhole cracks that total up to 20 thousandths, which makes it harder. What you're looking at here, if I pinch off and seal this hose and use my test port, the only thing I'm testing is the solenoid at the top for purge down to this hose. Now that's a lot of hose. It goes down behind the engine, goes to a lot of places for a leak. But I can go in and test this part of the hose. If it passes, at least I know I haven't got to look for smoke in that area. Let me say that again. If I pinch this off and block everything off going to the canister from the purge and all that hose coming from the engine, if I pass this and I have no leak, I've solved about 1/3 of my system, maybe 50% of my system, divided it almost half. I don't have to look all up behind the engine and everywhere else this hose goes because I have no leak. Now it's either out here at the vent or it's at the tank, and I can go through and set up other places. I can come out here, find this point, and use clamping pliers to block off different parts of this to isolate which part has it. I can disconnect the hose, put my smoke machine directly into here, and look at flow on that portion. Remember, that portion of the system should be sealed. If I'm going to the fuel tank, for instance, leaks from the top of the tank, hard to locate sometimes. Maybe I want to do that. Leaking fuel caps will show up there. I can plug it in here, see a leak, change the cap. Does the leak change? No. Then the cap is not the problem. Yes, it changed, but not enough. Oh, the cap was part of the leak, but not all of it. We cannot emphasize enough, this flow testing with a flow meter saves you worlds of time and makes your life a lot easier if you use it properly. So here we go. I've got my calibrated flow. I'm going to hook it up and say, this is what I'm looking for. I've got to beat a 20 thousandths leak because I've got a 2 thousandths or later vehicle, and I'm going to set the system. So I'm going to check it for its flow. Do I have normal flow? Boom. Do I have no leaks? I'm sealed up. Yes, I have no leaks. I passed the test. I got a small leak. Not bad. I got one right at 20 thousandths. Right at 20 thousandths. I got one of those things that may be an intermittent code. You cannot release this vehicle. I could release this. I don't have to have a perfect system. But here, I'm failing it. Now, if it's a 1996 to 1999, I'm okay because that red dot at the top is a 40 thousandths, and that's what it detects. Know what you're working on. If I'm working 96, 97, 98, 99, use the one at the top. That's 40 thousandths leak. If I use the one at the bottom, it's a 20 thousandths leak, and I got to fix it. If I'm up here, same thing. 20 thousandths, 2000 and later, this is no good. 1996 to 1999, I'm okay. Halfway there, but I'm still okay. Here, I fail everybody. You may get a code here saying leak detected 40 thousandths. Be careful. If you're working 2000 later, this just tells you how easy it should be to find it. It's much easier to find a 40 thousandth leak than a 20 thousandth. But don't think just getting it past this 40,000 is going to be good, because once it passes this test, the next time it runs a test and passes 40, then it's going to test for 20. So there's 2 tests done on the newer cars. A 40 thousandths engine running, and then a 20 thousandths with the engine off in many cases. There's 2 separate tests. If you fail the 40, we don't do the 20. But if you make it so it passes the 40, then it's going to test for 20, and you may have a comeback. We're trying to eliminate these. Big leak, something big's going on. You should be able to find it with smoke, not a problem. So we've already talked about isolating this. The purge solenoid could be leaking. If we block that off and it's leaking, we can find it and go up and test it. Very simple. Make sure you limit all these things one at a time. Boom, we blocked it off. There is no leaks. Then we select another point. That part is good. What else could we test? We can look at these other systems. Let's say we decide to go out here, plug our smoke machine in here, and isolate the tank and filler cap, and test just that. We're testing all the fittings on top and the filter cap. If our leak is there, boom, we found it. If not, we pass the first one. We do this when we pass it. Look to the right. We got the canister and the vent solenoid, and the vent solenoid is a high failure device. Particularly if you're looking for 20,000 smoke, you want to isolate it to a smallest area you can and look in that area. If we pass both of these red hoses and we had no leaks, There are cracked and broken canisters caused by collision damage. We'd go there and focus that area for our smoke. If we fail at the tank, focus that area for the smoke. Had we failed on the one going back to the engine, we'd have focused that area. So go in and look in the area where you think it might be and start looking for deformed and broken hoses. Here's a good example. Look at this abrasion. You can see it there. And here's our smoke coming out. This is a nice big leak. It's easy to find. I wish they were all this easy. Here, if you look carefully, there is smoke coming up from behind the engine. You see it coming over the side here. Where's it coming from? Well, that's the hard part. What do you know here? This is the hose leaving the purge, going to the canister. Rather than kill yourself wondering where it's coming from, it's leaking, it's behind the engine, replace the hose. Don't make this something that's impossible. This is not rocket science. This is just a Chevy. What we like is this Star environmental system, environmental technology, uses the dye. If we get a small leak and we pump enough of it under there and we can't see it, we can start taking things apart and use a black light with the ultra trace UV dye to find a place we might not be able to see, like we did behind that engine when it's leaking and it's totally out of sight. So utilize this leak testing. Go over it several times till you understand it.